This is video 3 for lesson 1 in unit 8 gases for chemistry 1. So we have been looking at our different units in variables for gases, and we have talked about volume and temperature. Our third one is pressure, and pressure is defined as the force per unit area. It's an interplay of gas molecules and the force of gravity that creates what is called atmospheric pressure. So all of the gas molecules that are in our atmosphere are being forced downwards towards the Earth due to gravity. And that means that our lowest levels of the atmosphere in which we reside have more gas molecules than the higher levels, which is why people have to wear supplemental oxygen tanks if they climb very high mountains because there's not as many gas molecules to breathe there. We measure pressure using a device called a barometer. And a barometer just presses down on our gas molecules, and we measure the height of a column of liquid. So I do have a diagram in your handouts that shows a barometer, and that's what this is right here. So if we had a pool of mercury down here in this beaker, which would not be very good to have around, and we also have an inverted tube in which we have mercury that the air has been removed. The pressure of all the gas molecules pushes down on this and it causes a column to rise. The difference in the height of the column versus the surface of the pool of mercury is how many millimeters of mercury the atmospheric pressure is. So the higher you go, the less this pushes down because there's fewer gas molecules, the lower this is. If we go down below sea level, then this is pressing more and the higher the column is. Now, because of that, we have different measurements or different units that are going to be in our pressure units. Millimeters of mercury have been renamed torr, and these are exact numbers. These are all equal to something called an atmosphere. An ATM is an atmosphere. So an atmosphere is the pressure at sea level, 760 millimeters of mercury. We here at Ligonier are not at sea level. We are at a higher altitude, so our pressure is a little bit lower. There's another unit called a Pascal named after the French scientist. Well, 760 millimeters of mercury is equal to 101,325 pascals, or 101.325 kilopascals. We can also convert the millimeters of mercury into inches of mercury, and we get 29.92 inches of mercury. That's typically what is used in weather forecasting when they give you the pressure. And those of you that are maybe in automotive, pounds per square inch, also called PSI, 14.70 is atmospheric pressure at sea level. So going back, the higher the altitude, the lower the atmospheric pressure. So these are our most important conversions. They're on that sheet that you have to reference, and we are going to learn how to convert these two, or these measurements, into one another. So when we go to convert 735 millimeters of mercury, first to atmospheres, then to kilopascals. So we're going to use our conversions just like we always have. We start with what we're given, 735 millimeters of mercury. And then we have to find one, these are all equal. So one atmosphere is equal to all of these. So 760 millimeters of mercury is what we want to get rid of. So that goes down on the bottom, and that is equal to one atmosphere. So now we divide these two. and we get 0.967 atmospheres, 3 significant figures because our original measurement had 3 significant figures. Now, if we want to convert that original measurement into kilopascals, all of these things are equal to one another. So 760 millimeters of mercury is equal to 101.325 kilopascals. So we put our 760 millimeters of mercury in the bottom so the units cancel, and 101.325 kilopascals on top. So we take 735 divided by 760, hit equals, then multiply by 101.325. And we get this number here, 97.99194079. 3 significant figures gives us 98.0 kilopascals. Go ahead and try this second set, inches of mercury to torr and inches of mercury to atmospheres. You can pause now. Welcome back. So if we want to change 67.92 inches of mercury into torr, again, inches of mercury, 29.92, is equal to 760 torr. It's all about canceling units. So 29.92 inches of mercury goes in the bottom, and the 760 torr goes on top. So in a calculator, 67.92 divided by 29.92, then multiply that by 760, and we get a rather large number, but we need 4 significant figures. So we end up with 1,725 torr. To change that into atmospheres, (67.92 inches of mercury). Well, 29.92 inches of mercury has 1 atmosphere. Our inches of mercury cancel out. We're left with atmospheres. So 67.92 divided by 29.92 gives us 4 significant figures, 2.270 atmospheres. There is our answer. And then our last variable are moles. Moles are the number of moles of gas per unit volume. So our units are moles, and it's given a little symbol of N in gases. This is not going to be used as much for us, but I just wanted to mention it. The last thing in this video is going to be something called standard temperature and pressure, or STP. This is a reference point because all the different labs that people work at might be at a different temperature, a different atmospheric pressure. So if they do experiments with gases, we have to have a reference point in which to do calculations. So we correct all of our variables and our volumes to what is called standard temperature and pressure. And that is defined as 1 atmosphere and 273 Kelvin. This set is very important for us to know because we are going to be using it. So if we need a temperature or a pressure at standard values, we should reference these 2 values. Standard temperature is 273 Kelvin. Standard pressure is 1.00 atmospheres.